Right, what we're going to do is we're going to look at problem 8 from the example paper. So first thing we're going to do is obviously read the question, but remember what we're looking for is what standard algorithm is it. Now this one is the linear search, but I'm going to show you why it's the linear search. So it says here, a list of 8 scores for a game is stored in a 1D array shown below. So here's my array here, my array is clearly called scores, and here is the index for my array. So remember, I use element quite a lot, but index and element are the same thing. So 16 is in index 0, 12 is in 1, 19 is in 2, 20 is in 3, 17 is 4, 8 and 5, 13 is in index 6, and 19 is in index 7. Now, here's my problem here. An algorithm will ask for a target score, so I'm asking the user to enter something, and then what it'll do is it'll find all the scores in the array that are this target, and then it will reduce them by 10. So for example, if the target score entered is 19, then what the array becomes is this here. So look, everywhere that there's a 19 up here, down here it's now a 9. So I've got a 19 in position 2, and I've got a 19 in index 7. So when I come down here, if I go to 2, it's now 9, and I go over here, it's 7, it's now 9. Now look how long I'm taking having a look, read and having a look at what's been given. If there are diagrams in your paper, in your question, they're there for a reason, and you've got to have a look at them, and then that'll help you work it out. You also know in class that when I do these, I will always draw out the array so we can discuss exactly what's happening with the element. I just find that helps. So 16 isn't touched, 19 isn't touched, so I'm asking the user to enter something, and then I'm going through my array, I'm looking for that something, and then I'm carrying out an action. So clearly that's a linear search. Now remember what your standard algorithms are. Input validation, probably not going to be in your exam because that's National 5. Doesn't mean it won't be, just means probably won't. Linear search, count occurrence, find min, find max. You have done all of these loads of times. Remember, your count occurrence, your find min, your find max, these are all linear searches because you need to find something before you can work out if it's the min, you need to find something before you can work out it's a max, you need to find something before you can work out that it's count occurrences. So they're all really linear searches. So let's have a wee look at what's been written down here for us. Here's the algorithm. So I've only got 2 lines that we want to write in. I've got the conditional statement, and then I've got the action. Well, we know the action is to reduce it by 10, and we know the conditional statement is look for something. So set my scores to, and it's my array, so clearly we know that scores is the name of the array, but there it's set up for us. Receive the target, so there's my 2 variables that I need to use. So I've got scores, which is my array, and I've got target, which is what's been input by the user. In the example above, it was the number 19. So what I need to do is, over my bit of paper, I'm getting ready to write down if, and then I'm getting ready to write down the number 5. So in here is my for counter is from 0 to 7. So counter, when we do this, we usually use I all the time in our for statements. Now that, to be honest with you, let's not pretend otherwise. That's because we're lazy. We can't be bothered writing the word counter every time, so we write the letter I. Of course we know that I stands for index because that there is you going through the index. So we would normally have I, but whatever they give you in the exam, that's what you're going to use. So go to position 0. Now what is it I want to know in scores at position 0? Well, I want to know if that is equal to 19. So scores at position 0, is it equal to 19? The answer is no, but how do I write that? So over here, what I would be writing is, I would be writing number 4, and then I'd write my if statement. So it's scores, and it's at position 0, but remember, we wouldn't write 0 in there because we need to do it 0, 1, 2, 3, 4, 5, 6, 7. That's why it's inside a loop. So what variable goes from 0 to 7? Normally for us it would be I, but in this example, it's counter. So if scores at counter is equal to 19, but 19 is stored in a variable, well, what variable is 19 stored in? Receive target from keyboard. 19 is stored in target. So if scores at counter is equal to target, then, so I'm at 0, is scores at 0 equal to 19? No, it's not. So let's increment counter. So it now goes from 0 to 1. Is scores at counter equal to 19? No, it's not. And I realise I'm doing it in the wrong one, so let's jump up. Is scores at counter equal to 19? Well, at position 2, yes it is. So what is it I want it to do now? I want it to take 10 away from this here. So, when I come back, I could write, and then I'll explain to you why it's wrong, set scores at counter to equal 19 minus 10. Yep, that's going to work. However, that means it will only, if the next time we run the program, let's say it's 20, I want 20 to be reduced by 10, that there would become 9. It's not what I want, so I can't write 19 here. I have to write my variable, which is of course target. And that there is how you get the 2 marks.